Algebra 1 7.10, this is reasoning strategies, and we're going to talk about how you can simplify the problem as a strategy. When we're presented with a complicated problem, we might be able to solve it by solving a simpler version of the problem or simplifying the problem we're given. So if we have 2400 over 600, it could be thought as 24 over 6, can't it? Those zeros aren't that important. We can just solve it. Well, by substituting smaller numbers, the problem can become easier to solve. We can even solve a series of simpler problems to solve the difficult one, and gradually increasing the values. And we can list the increasing values in a table to stay organized. That table can help us find a pattern and solution to the original problem. We could even try drawing a diagram or a picture. That could help us too, couldn't it? So if we're stacking red plastic cups in a pyramid shape with a triangular base, how many cups would we need to make a triangular pyramid that is 10 cups tall? Now, you have to remember what a triangular pyramid is. I've got one right here, and hopefully I won't drop it. But you can see there's 3 triangles. See that? And the base is a triangle. So if we're going to stack cups in this triangular pyramid, we're going to need a base that's a triangle, and then it's going to gradually get smaller as it goes up, isn't it? We can simplify this problem by finding how many cups we need for a smaller pyramid. Then we can look for a pattern. So if we have 1 cup, that's going to be 1 layer. Now we can't have 2 cups on the first layer because one would just go right on top of the or on the second layer, because one would go right on top of the other one, wouldn't it? And it would just swallow it up. But for our second layer, if we put 3 cups at the base and then 1 on top, then we'd have 4 cups total, wouldn't we? And that would be 2 layers. So 2 layers would be 4 cups. Then in order to do 3 layers, we'd have 10 cups, because now we can put another one here, right? And another cup here and another cup here, right? And then that means we can stack another one like this and another one like this, and we would just slowly keep stacking them so that the edges were touching each other, and then we would slowly bring it up. Well, what's happening in this pattern is, as our layers are going up by 1, our cups are going up by 3. 1 plus 3 is 4. Then by 6, 4 plus 6 is 10. And then it goes up by 10. 10 plus 10 is 20. Then it goes up by 15. 20 plus 15 is 35. Then it goes up by 21. Now what's happening here with this 3, 6, 10, 15, 21... what's happening with these numbers is they're going up by 1. See? Just like the layers are. We add 3 to 3 and we get a 6. See? And then we know to add the 6 and the 4 together. Now if we add 1 more to this 3 and get a 4, then we know to add 10 to the next one. And if we add 5, 1 more than 4, to the 10, we'll know to add 15 to the next one. So we've got to go down a whole nother level to find out where the pattern is. And this pattern is going up by 1, which makes the addends go up by 1 each time, so that we can add the addends. And when we get to the 9th level and then the 10th level, we can see we need 220 cups for 10 levels. Well, we can extrapolate, can't we? Remember when we were doing the scatter plot with the outliers, and we had interpolate to find the data that was inside our given points, and we can extrapolate outside of the coordinate plane, outside of our given points. We can find out that 11 would be 286 cups, because after we get here to 55 added to the 165 to get the 220, we can see that the next thing to add to the 55 would be 11, wouldn't it? Because we're going up by 1. So 55 plus 11 would be 66. We'd add that to the 220, and we'd have 286. We could do 12. After this 11 that we added and got 66, we could add 12, couldn't we, to 66 and find out what 12 layers would be. And we could keep on going and going, couldn't we? All right, so how about this one? To find the number of different squares that can be found in a grid, we can use the same strategy of solving a simpler problem. Now, if we have a table that's 7 squares across and 7 squares down, then we can start with 1 times 1, that's this little red square, then 2 times 2, that's that blue square. Then we could do 3 times 3, that would be this green square right here. Then we could do 4 times 4, this orange square, and then the lime green square is 5 times 5, see? And then a yellow one is 6 times 6, and then the entire grid would be 7 times 7, because there's 7 going across and 7 down. Now, did you know that if we find the products to these multiplication problems and we add them together, it'll be 140, and that is how many unique different squares that you could find in a 7 by 7 grid. Isn't that cool? You could do it in an 8 by 8 grid or a 9 by 9 grid or a 5 by 5 grid, whatever. But if you use this method of starting with 1 times 1, then 2 times 2, and then going up to 7 times 7, because that's how many squares there are, you'll be able to find out how many unique squares there are. And by unique squares, I mean each one of these separate little ones is unique, but then there's a square here, isn't there? And that's not the same as this blue one up here. And there's a square right here in the middle, isn't there? See? That's a unique square. So there are 140 unique squares in a 7 by 7 grid, and if we add up the products, we can find out how many unique squares there are. Okay? You can try this with your friends and family and see if they can figure out how many different unique squares there are in a grid. Our next video is 8.1a. We're going to be talking about systems of equations. We're going to identify solutions. And of course, like always, if you want links to previous videos like proof of slope m, which we just finished, or to learn about the point-slope equation or slope-intercept equation, or about parallel lines and perpendicular lines and working with equations with those and graphing them, you can look in this video's description and there'll be links that you can just click on, okay? Make your life easy. All right, we're going to move on to Chapter 8 and systems of equations. I hope this was helpful. I hope you're doing okay, and I'll see you next video. Bye.